show that the vector 1 comma 1 comma 2 comma 4, 2 minus 1 minus 5 minus 2, 1 minus 1 minus 4 0, 2 1 1 6 are linear independent in r power 4. So r power 4 is nothing but we have the set of elements in the vector as 4. So here we must, after finding whether it is linearly independent, we must check that we must select the linearly independent subset. Also we must find the dimension and the basis of the subspace which is spanned. So here we know that spanned means the linear combinations. So here we must check the linear independent. So linearly independent means combination of first vector c1 v1 plus c2 v2 plus c3 v3 plus c4 v4. So we have the set of 4 vectors multiplied with some constant c1 c2 c3 c4 and added, we must get 0. It is nothing but if all the values of c2 c1 c2 c3 c4 equal to 0, then it is linearly independent. Suppose any of the values are not equal to 0, then we call it as linearly dependent. So here c1 multiplied with the set of vectors. So here we write it this one in terms of column vector. So c1 into 1 1 2 4 in terms of column plus c2 into 2 minus 1 minus 5 minus 2 plus c3 into 1 minus 1 minus 4 0 plus c4 into 2 1 1 6 equal to 0. So here first element we write it in terms of matrix. First element of the first vector 1, second one 2, third vector 1, fourth vector 2 equal to 0. We are writing in terms of matrix format. So second element in the first vector 1, second vector minus 1, third vector minus 1, fourth vector 1 0. Similarly third one 2 minus 5 minus 4 1 0, 4 minus 2 0 6. So here we have written the matrix format. We must simplify this one. So here R2 is nothing but the elements are same. We can write R2 minus R1. R3 can be written as R3 minus 2 times R1. So here first row first element is multiplied with 2, we are getting first row third element value. Similarly R4 is R4 minus 4 times R1. So first row we write it as it is 1 2 1 2 0. So R2 minus R1, 1 minus 1 is 0, minus 1 minus 2 minus 3, minus 1 1, minus 1 is minus 2, 1 minus 2 1 minus 2 is minus 1 0. So all are negative, we can write it as positive value, and here this one R3 is there. So R3 is nothing but 2 minus 5 minus 4 1. 2 times R1, first equation multiplied by first matrix, row matrix will be multiplied by 2. So 1 into 2 2, 2 2s are 4, 2 4 0. So we subtract this one, 2 minus 2 0, this is minus 9, this is subtract, minus symbol minus 6, put minus symbol here, 1 minus 4 is minus 3 0. So here each and every element is multiplied by 3. We can divide this one with 3, we get minus 3, so we get 3 2 1 0. So here we can write as it is, otherwise we can write minus minus minus, there is no changes. We can write plus or negative. Now similarly R4 is 4 minus 2 0 6. Then R1 is multiplied by 4 times, so 4 2s are 8, 4 8 0. So this, subtract this one, we get 0 minus 10 minus 4 minus 2. So we can divide this one. So here we write 0 5 2 1 0. So next we see that second row second element is not equal to 0. With help of this one we should make this as 0. So here 1 2 1 2 0. Second row we write it as it is, 0 minus 3 minus 2 minus 1 0. Third row we can see that all the elements are same. R3 is nothing but R3 minus R2. So straight away we can write it as 0 minus 3 plus 3 is 0 minus 2 minus of minus 2 is 0 0 0. Now we must check with the simplification of the last row. R4 is, so here 5 times R2 we multiply, both the symbols are same, plus 3 times R2 R4. So here 5 times R2 is 0 minus 15 minus 10 minus 5 0. R4 multiply with 3, 0 15 6 1 3s are 3 0. We add this one, 0 minus 4 minus 2 0. So if we simplify this one, we can write it as 2 1 0. So last row we are getting 0 0 2 1 0. So here one row is 0. So here R3, all the elements are 0. So here we are getting linearly dependent. So the set of vectors form linearly dependent. Why? Because rank is 3. That means we are getting only 3 value as answer. So here we do the modification of this one, 1 2 1 2 0 0 minus 3 minus 2 minus 1 0 0 0 2 1 0 0 0 0 0 0. So here we must get all the element as 0. Here last row 0, so we cannot say that C1 also 0, C2 also 0, C3 also 0, C4 equal C4 also 0. Why? Because the third row we can write it as 2 times C3 plus C4 equal to 0. So here 2 times C3 equal to minus C4. So here C4 is the last row, last column. We have 0. We cannot assign 0 for C4. So C4 is the free variable. So here C4 is free variable. That means we can assign any value. that is C4 is not equal to 0, C3 is not equal to 0. So C3 is not equal to 0. Similarly, we get C2, C1 also not equal to 0. Hence, it is not linearly independent. The set of vector is linearly dependent. So here we are getting linearly independent. We must find out the subset. How many variables are not equal to, how many rows are not equal to 0? So here we see that 3 rows having some elements which is not equal to 0. Hence, we say that, so we have interchanged this one. We have interchanged the rows, last row. So row 1, 2, 4 form a linearly independent subset. Row 1, row 2, row 3, row 4. So here we can see that 4 minus 2 0 6, that row get 0. We write other elements, those elements form the set of vectors which are linearly independent. So here dimension, so dimension is 3, dimension 3. So why? Because we have 3 rows having some elements which is not equal to 0, and we can write the basis the problem by using row space also.